Imagine an era where decisions are not based on gut feelings, but on hard data and predictive analysis. That's where we are, thanks to data science and machine learning. These two fields have revolutionized our approach to understanding the world around us. They allow us to dive deep into the oceans of data we generate every day, uncovering trends, predicting outcomes, and guiding our decisions. Consider how businesses no longer need to rely on hunches or intuition. Instead, they use data science to analyze customer behavior, market trends, and operational efficiency. Machine learning, on the other hand, takes this a step further. It trains computers to learn from this data, making predictions and decisions without explicit programming. From personalized product recommendations to predicting stock market trends and even diagnosing diseases, the applications are endless. Data science and machine learning are not just buzzwords, they're tools shaping the future. Imagine being able to find hidden patterns and trends from a mountain of data. That's what data mining and big data analysis allow us to do. Now let's dive right into the crux of data mining. Picture it as a treasure hunt where the treasure is buried in a massive pile of information. The tools we use in this hunt are algorithms designed to sift through the data, looking for patterns, correlations, and anomalies that can give us valuable insights. It's like panning for gold in a river of information, where the gold nuggets are those precious insights that can drive informed decisions. But what happens when our river of information turns into a flood? That's where big data analysis comes into play. As the name suggests, it deals with enormous volumes of data, too vast for traditional data processing tools to handle. We're talking about terabytes, petabytes, or even exabytes of data, coming from various sources in various formats and often in real time. So how do we make sense of this deluge of data? The answer lies in advanced analytical techniques. These can range from predictive analytics, which forecasts future trends based on historical data, to machine learning algorithms, which learn from the data and improve their performance over time. The goal? To extract meaningful insights that can guide actions and decisions. One of the key challenges in big data analysis is dealing with the sheer speed of data generation. Think of social media feeds, stock market transactions, or Internet of Things devices. These sources are constantly churning out data, which needs to be analyzed almost instantly to be of any use. This is where real-time analytics come into play, allowing us to monitor and respond to events as they happen. But remember, data mining and big data analysis are not just about crunching numbers. They're about understanding the story that the data tells us. They're about finding the signal in the noise and transforming raw data into knowledge and wisdom. The ability to mine and analyze data provides us with the power to make informed decisions and predictions. In a world where data is the new oil, it's these insights that can give us a competitive edge, driving innovation and shaping the future. Scene script. Data is just numbers and figures until it's presented in a way that makes sense. That's where data visualization and storytelling come in. Imagine a complex dataset with thousands of data points. It's like a tangled ball of yarn. Data visualization is the process of untangling that ball, arranging the threads in a way that we can see the patterns and understand the story they're telling. Data visualization is not just about making pretty charts and graphs. It's about clarity. It's about taking something complex and making it accessible. It's about transforming data into a form that our brains can easily process. Think of it like this. Our brains are wired to process visual information far more efficiently than raw text or numbers. That's why we respond so much better to a well-crafted chart than to a spreadsheet full of numbers. But visualization is only half of the equation. The other half is storytelling. You see, data doesn't speak for itself, it's silent. It's our job to give it a voice, to tell its story. And like any good story, a data story needs a narrative. It needs a beginning, a middle, and an end. It needs a plot and characters. It needs tension and resolution. The narrative is what guides us through the data. It tells us what to focus on, what's important, and what's not. It helps us make sense of the patterns and trends we see in the visualizations. And most importantly, it answers the question, so what? It tells us why the data matters, why we should care, and what we should do about it. Data storytelling is a powerful tool. It can persuade, inspire, and motivate. It can drive change and action. It can transform abstract numbers into meaningful insights that can be understood and acted upon by anyone, not just data scientists. But remember, with great power comes great responsibility. It's crucial to ensure our visualizations and stories are accurate, ethical, and respectful of the data's limitations. We must always strive for truth and fairness in our data stories. Data visualization and storytelling turn raw data into insights that can drive action. They make data not just understandable but actionable. And that's the real magic of data science. Businesses today are harnessing the power of data in unprecedented ways, but this power comes with responsibility. In the quest for improved performance and more informed decision-making, companies across the globe are turning to data science. By leveraging machine learning algorithms, businesses can train predictive and classification models, unveiling patterns and trends hidden within their data. This process is akin to panning for gold in a river of information, where the nuggets of insight can lead to significant improvements in business performance. For instance, a retailer might use data science to predict which products will be popular in the upcoming season, allowing them to stock their shelves accordingly and reduce waste. Similarly, a financial institution could use these methods to identify patterns of fraudulent activity and halt it before it becomes a severe issue. However, as we delve deeper into the realm of data, ethical considerations and privacy concerns inevitably surface. The data often used in these processes can be sensitive, containing personal information about customers or employees. Therefore, businesses must tread carefully, ensuring they comply with privacy regulations and respect the rights of individuals. Imagine a healthcare organization using patient data to improve their services. While this has the potential to revolutionize healthcare delivery, it also poses significant privacy risks if the data were to fall into the wrong hands. Therefore, such organizations must take stringent measures to safeguard this sensitive information. Moreover, there's the ethical issue of transparency. With machine learning models making increasingly complex decisions, it's vital that businesses can explain how these decisions are made. This is especially important in sectors such as finance and healthcare, where decisions significantly impact people's lives. In this age of big data, businesses have a responsibility to not only use data to their advantage, but also to protect the individuals whose information they hold. They must strike a balance between harnessing the power of data and respecting the rights and privacy of individuals. In the business world, data is a powerful tool that must be used responsibly. To harness the power of data, you need the right tools. For many data scientists, those tools are Python, R, and data engineering techniques. Imagine a world where data is like clay, and Python and R are the sculptor's tools. Python, with its simplicity and versatility, is a favorite among beginners and experts alike. It's not just a language, it's a community. A community that has built numerous libraries like Pandas for data manipulation, NumPy for numerical computations, and scikit-learn for implementing machine learning models. It's like a Swiss Army knife for data scientists. On the other hand, R, another powerful language, was specifically designed for statisticians. It's like a surgeon's scalpel, precise and purpose-built. With its robust package ecosystem, it's great for statistical modeling, hypothesis testing, and creating stunning data visualizations. But you can't start sculpting until you have your clay, right? That's where data engineering comes in. It's the process of collecting, storing, and preparing data for analysis. Data engineers lay the groundwork. They build the pipelines that fetch data from various sources, clean it, transform it, and store it in a format that's ready for analysis. It's not as glamorous as predicting stock prices or detecting fraud with machine learning, but without it, data science is like a car without an engine. Remember, Python and R are just tools, and tools are only as good as the hands that wield them. They each have their strengths and are often used together, complementing each other. The choice between Python and R often depends on the specific needs of a project and the skills of the team. In essence, Python, R, and data engineering form the backbone of data science. They enable data scientists to sift through the noise, find the signal, and use that signal to make informed decisions. They are the means to the end, the tools that turn raw data into something meaningful. With the right tools and techniques, data scientists can turn raw data into actionable insights. In a world driven by data, the ability to predict future trends is invaluable. That's where time series analysis comes in. Time series analysis is a statistical concept that deals with a sequence of data points collected over time. These points are typically collected at regular intervals. Think daily stock market prices, quarterly revenue reports, or annual population metrics. By analyzing these sequences, we can identify patterns and trends that have occurred over time. This can provide a wealth of insights, allowing us to forecast future occurrences based on past data. It's a powerful tool widely used in diverse fields like finance, economics, social science, and even meteorology. Imagine being able to predict stock market trends or foresee a country's economic growth, or even anticipate weather patterns. That's the power of time series analysis. By analyzing past data, we can predict future trends and make more informed decisions.